Okay, good morning, everyone. Salam sejahtera. Okay, so today we are going to learn equilibrium of a rigid body. So, what is the meaning of equilibrium? Equilibrium meaning there is balance. Okay, or in other words, seimbang. Okay, so torque is the vector or cross product between the distance of the force from the rotation exit with the acting force. So we can write as torque equals to R vector R cross vector F. Okay, or we can write as R F sine theta. Okay, because it's a cross product. So we write as sine. Okay, so what is the meaning of torque? Okay, previously in a linear motion, we say F equals to ma. Okay, so torque actually is the tendency of the force to rotate, okay, an object about some exit. So for example, let's say, this is the pivot point. Let's say we write superstar here. So meaning that pivot point is a rotational exit. Okay, so from this pivot point or the rotational exit, it's like our reference point. So from this point, this is our R, okay, and then this is our F. So the angle here is between vector R and also vector F. Okay, so for example, let's say this is a dot. Okay, a dot. Okay, and this is your pivot place. Okay, so if let's say you acting a force at point A and point B, okay, with the same magnitude F equals to, let's say, 10 Newton, same force. Okay, so at point A or at point B, we will experience a maximum torque. Or at point A or at point B, which one is easier to rotate? If let's say the door want to open, okay, which point you will get the most easily the door will open. Okay, so if let's say this is your R, 1 meter, 1 meter. If let's say we calculate torque at point A, okay, meaning that RF sine theta is from this reference point, our R is 2 meter. Okay, F is acting upward. Okay, so it's 10 is sine 90 degree. Okay, so you will get 20 Newton meter. Okay, for torque on point B is RF sine theta, but from the reference point until point B, only 1 meter. Force acting on point B is 10 Newton, and the angle between R and F is actually 90 degree. So you will have 10 Newton meter. Okay? So meaning that at point A, you will have greater torque. Okay, meaning that at point A, your door is easier to open or easier to rotate. Okay, so torque is the tendency of the force to rotate, meaning that when your torque is greater, meaning that your door or your object is easier to rotate. Okay, torque is a vector quantity, meaning that we need to consider the direction and also the magnitude. And the unit for torque, because it's FR, so it's Newton meter. The directions of torque is parallel to the axis of the rotation. Okay, so this one you must take note where if your torque is positive, meaning that it will rotate in anti-clockwise. Okay? If your torque is negative, meaning that your object is rotating clockwise. Okay? So this one you must take notes. Okay, next we go to exercise. Okay, here we have A and point B with the length 4 meter. Force acting on point B is 30 Newton. The first one, calculate the torque at point A. So meaning that point A is our superstar. This is our private point or the reference point. Okay, the reference point. Okay, so our radius from this reference point until the point B. P is the point that F 30 Newton exacted. So our radius is 4 meter and the force is acting upward. Okay, so the first one, torque at point A is RF sine theta, where your R from the reference point A is 4 meter. Force acting on this rod is 30 Newton. Sine, the angle between the radius and the force is 90 degree. Okay, so you will have 120 Newton meter for questions number 1A. Okay, can you understand? Okay, next. Okay, next, calculate the net torque at point B. Okay, at point B. So we need to write our reference point at point B. So this is our superstar. Okay, so F equals to R, not F, torque. Okay, your torque equals to RF sine theta. Okay, so R here is the reference point, the distance from the reference point. Okay, so when you choose B is your reference point and the force is acting at B, meaning that your radius actually is 0. F is 30. Okay, so anyhow you will get 0 because of your radius is equal to 0. Okay, so you will get 0 Newton meter. Okay, we try next questions. So the rod is 3 meter, exacted 40 Newton. Calculate the total torque at point A. So point A is our superstar. Okay, so radius from point A to the acting point where the force acting is 3 meter. Okay, so we write 3 meter. Force acting on this rod is 20 Newton. Sorry, not 20, is 40 Newton. Okay, it's 40 Newton. Okay, sine, the angle must between the radius and the force acting. So the angle is 20 Newton. Okay, so please calculate 3 times 40 sine 20, you will get 41.04 Newton meter. Okay, so this is the torque from point A. Okay, where you will get 41.04. Okay, next questions number 3. Number 3, the figure shows the 8-meter rod exacted 50 Newton forces. Calculate the total torque at point A. So your point A is like your reference point, okay? Meaning that everything also we must refer to the point A. So from reference point A, go to the point that your force acting. Your R is 6 meter. Okay, so torque equals to RF sine theta. R is 6 meter. Okay, F is the force acting on the rod, meaning that it is 50 Newton. Okay, sine angle must be between R and also F. So this is the total angle. Okay, so this is 90 and sine is 90 plus 30. Okay, so 300 sine 120. Okay, you will get 259.81 Newton meter. Okay, so this is for torque. How to find the torque RF sine theta? 3 questions. Okay, so that's all for 8.2a. 8.2a.